Okay, so what we're going to do is a little bit of practice with balancing chemical reactions, or I should say balancing chemical equations. So this is from your practice packet. It's lesson 1, and we're going to do number 1 through 9. Okay, so we look at the first one here, and again, what we're trying to do is make sure that we have the same number of each element on each side of the equation. And when I say the side of the equation, I mean if you look at the arrow, that would be the left side, and that would be the right side. So, just remember, subscripts go to the element that it follows. So in other words, that would be 2 oxygens, 4 hydrogens, 2 oxygens, etc. If we put a number in front of a compound, it's going to distribute. So if we put a 2 in front of H2O, that would distribute to the hydrogen and multiply, so that would be 4 hydrogens, but also distribute to the oxygen, so that would be 2 oxygens. So subscripts are for the element it follows only. Coefficients distribute to each element in the formula, and they also multiply. Okay, so it really is a matter of counting. So when we look at this equation, we're going to look to the left, and we have 1 mercury, and over here we have 1 mercury. So that's good. Over here we have 1 oxygen and 2 oxygens, so we need 2 on the left side. So again, the only thing we can do is put coefficients. We can't just put a subscript of 2 there, because then we would change the formula. So that would give us 2 oxygens, but now we have 2 mercuries, so we need to put 2 mercuries on the right side. So everything should balance out. 2 mercuries, 2 mercuries, 2 oxygens, 2 oxygens. Let's take a look at the next one. So when I look at this, what I see are, first of all, I see the subscripts. So you have to pick something to start with, and you can just start reading left to right, or you can look for something that might be easy. So when I look at this, I see 2 hydrogens, and over here I see 1. So I'm just going to put a 2 there, and that's going to give me 2 hydrogens, 2 hydrogens, 2 chlorines, 2 chlorines, so that's good, 1 magnesium, and 1 magnesium. So our coefficients, when we don't have 1 written, again, it's implied that that coefficient is 1. So instead of writing 2, 1, 1, 1, we just leave them blank. So really, what you would do when you have no coefficient written, it's just implied that it's a 1. Okay, so let's take a look at this reaction. We've got CH4, so we have 1 carbon, 4 hydrogens, so I'm going to put a 2 in front of this water to make that 4 hydrogens. And on the left side I've got 2 oxygens. Now over here I've got 2 oxygens here, and I've got 2 there, so that's a total of 4 oxygens. That's 4 oxygens, not 40. So I need 4 on the left side, so I'm going to put a 2 there. So now I've got 4 oxygens. If we look at the next one, we can balance those carbons first. So over here I have 6. So I need 6 over here, so I'm going to put a 6 there. Hydrogens, I have 12. So to get 12 over here, I need a 6. 6 times 2 is 12. Now my oxygens, I have 2 and 6, which is 8. But over here I have 6 times 2, which is 12. And then 6 times 1, which is 6. So I have a total of 18 oxygens on the right side. So I just want to emphasize that you need to count up the total oxygens on the right side. So since we have oxygens in this formula and in this formula, we would add them up for a total. So over here I have 6, so I need 12 more to make 18. So if I put a 6 in front of that one, 6 times 2 is 12, plus 6 is 18. So that one was a little bit trickier than the others, but still not a big deal. Okay, let's move on. Okay, here's our favorite reaction that we've seen a number of times. So we have 2 hydrogens, so those are good. 2 oxygens. Now over here we have 1 oxygen. So to make it 2, we're going to put a coefficient of 2 there. Now that changes our hydrogens to 4, so on the left side we need 4, so I'm going to put a 2 there. 2 times 2 is 4. So everything's good. Over here, or the next one I should say, what you're going to notice here is you have 2 hydrogens and 3 hydrogens. Whenever you have a 2 and a 3, or a 3 and a 2 for that matter, what you're going to see is that you're going to have to multiply this side by 3 to give you 6, and then multiply that side by 2 to give you 6. So that's a pretty common occurrence when you have 2 and 3 on opposite sides. You just have to multiply them by a number so you get the same number of each. So 3 times 2 is 6, 2 times 3 is 6. So now our nitrogens, we have 2 and 2, so they balance out. Okay, the next one here, this is actually pretty tricky because you have 1 and 2 oxygens, so we have a total of 3 oxygens. And then over here you have a total of 2. So we have to do something to one of these sides so they're equal. The problem is, no matter what I put in front of that compound, I have to put in front of that compound also because my nitrogens have to balance. One thing you might want to try before you start just randomly picking numbers is multiply or put a coefficient, the same number in front of each of them, and see what that does. So we balanced our nitrogens, 2 and 2, but now we have 2 oxygens and 2 oxygens, which is 4, and then we have 4 oxygens over there. So that one balances easily by that technique there. Okay, the next one, as you can see, we have 3 oxygens and 2 oxygens again. There's that 3-2 issue. So I'm going to multiply by 2 and by 3, so I have 6 oxygens and 6 oxygens, and they balance. But now I've got to balance my aluminums. 2 times 2 is 4, so I need 4 aluminums there. This next one, what you'll find is 1 calcium, 2 hydrogens. Now when we have a subscript outside of the parentheses, that applies to everything within the parentheses. So we have 2 oxygens there, and like I said, we have 2 over here, 2 hydrogens, and we already have 2 hydrogens. So that one actually balances in a 1-to-1-to-1 ratio. So we don't have to worry about putting any subscripts there. Okay, let's move on. So now we're going to do some where we're going to write out the formulas and then balance them. So we have sodium, single element, not a diatomic, reacts with oxygen. Now oxygen's a diatomic, so we've got to put that 2 there. Sodium oxide, IDE ending. So that's single element, 2 minus charge, sodium, 1 plus. So when we crisscross, we get Na2O. Now the common question here is, people say, well, you've got a 2 here, why not a 2 there? This 2 and that lack of a 2 have nothing to do with one another. Remember, whenever you take 2 elements or 2 substances and bring them together to form a compound, you're thinking charges and crisscross. So that 2 is there because oxygen is 2 minus. That 1 is there because sodium is 1 plus. So just kind of keep that in mind as you're doing this. So we're going to balance our oxygens first by putting a 2 here. That'll give us 2 oxygens. And since we have 4 sodiums, we'll put a 4 there. Let's do the next one. Let's do the next one. Lithium oxide reacts with calcium nitrate. I'm going to have to squeeze this in here. Lithium nitrate and calcium oxide. So let's balance our lithiums. I'm going to put a 2 there. We have 2 nitrate polyatomics, 2 nitrate polyatomics, 1 calcium, 1 calcium. one oxygen, everything balances. Alright, hydrochloric acid, HCl, reacting with zinc to form zinc chloride and hydrogen gas. Now here I would have to tell you that zinc has a 2+ charge, chlorine we know, or chloride, we know is 1-, so when we crisscross we get ZnCl2. Like I said, I would have to tell you that zinc is 2+. And just remember, hydrogen is diatomic. So we have 2 hydrogens, so I'll put a 2 there, which will balance our chlorines, and our zinc is already there. Okay, let's just take a look at one more thing. Alright, and this is just going to illustrate mathematically our law of conservation of mass. So the question says, according to the following equation, let's assume we have 3.5 grams of hydrogen and we have 4.5 grams of oxygen. The question says, how many grams of water do we have? Assuming all of the reactants react. Later on in the year we'll talk about why not all of that will react, but let's assume that it does. So if we start with 8 grams, according to the law of conservation of mass, we have to end with 8 grams. So this is actually a very simple problem. Just remember, your total mass of your reactants is going to equal your total mass of products. And since the equation is already balanced, we don't have to worry about that. Okay, so those are the practice problems from your practice packet. So if you need to review those before the exam, there they are for you.